that means that if you want to engage oxygen in an electron transfer reaction, you need to add the electrons one at a time. So this is something that in a normal redox reaction, which always transfers electron pairs, that doesn't happen. So that has advantages. For example, the so-called spin restriction on the reactivity of oxygen prevents the spontaneous combustion of the atmosphere, which is a good thing. But it means that if you have unpaired electrons somewhere, such as in the mitochondrial electron transport chain, their chance of leaking to oxygen is very high. Oxygen is like the magnet for these things. So basically, the wire of the electron transport chain becomes poorly insulated in the presence of oxygen. Once such an electron leak in the mitochondria happens, you form something called reactive oxygen species. So a molecular oxygen that has only a single unpaired electron, and then we think that is a very, very dangerous thing to have.
So, basically, you want this electrical current flowing because it's enabling all of this amazing metabolic stuff to happen. But just like, I have electrical wires in the home that make, the lights and the TV and all of that possible. You want this to be well insulated. You want everything to be protected, and you don't want the electricity leaking and sparking and lighting your house on fire.
Exactly. And the leakiness also seems to be determined to some extent by how well the mitochondrial and the nuclear encoded electron transport chain proteins cooperate together. So every individual is different in that respect because the mitochondria only come from the mom and the nuclear genome obviously from both mom and dad. So every individual is a new experiment that has to find out how these two components actually work together. And it's even thought, I read somewhere, that one of the most common reasons of spontaneous abortions in humans is actually mitonuclear conflict. So very early during embryonic development, the mitonuclear match is checked, and if the match is poor and you leak a lot of electrons, the developing embryo at a very, very early stage undergoes apoptosis.
Yeah. So depending on who mom and dad were, the amount of leakage of these electrons can be greater or lesser. But in everyone, to some extent, there's always, it's never perfect. And there's always going to be some leakiness. There's going to be some reactive oxygen species. And that is an inevitable consequence of this oxygen-based metabolism.
Exactly. That's what we think is what's going on. And that's what we also think is the root cause of the need for sleep in animals that have neurons that are energy or power hungry.
Yeah. So, so this makes a lot of sense so far. If sleep is fundamental, meaning that we see it in everything from jellyfish to flies to mice to humans, it has to be serving some function that's also fundamental. And jellyfish don't have a hippocampus. Neither do flies for that matter. There has to be something that all of these animals need. And what they all have in common is this metabolism, this oxygen-based metabolism that uses mitochondria to create energy.
Exactly.
And so let's talk a little bit more about the side effects of aerobic metabolism here. So we're using oxygen as an electron acceptor. It's got advantages and disadvantages. When we have this leakiness in the mitochondria, when we generate reactive oxygen species, why is that bad?